Okay, in this video we're going to talk about calculating slope. The slope is the rise divided by the run. Okay, the rise is this way, and your run is this way. Okay, and you've probably done this in math. Okay, you have your change in y over your change in x. Okay, this will look something like this. You'll have y2 minus y1 equals x2 minus x1. And I know that you've done this in math, so don't tell me that you don't know how to do it, because I know you have. Now, if you have data like this, a lot of times we'll ask you to draw the best fit line. And a best fit line is a line that you draw as close to all the data points as possible. A couple things I usually see with students. They will purposely start it at 0 and do this. No, you do not have to start your best fit line at 0. Your best fit line does not have to touch the first and the last point. I see that a lot. They touch the first and the last. No, it's as close to all of the data points as possible. You can see that this one is not touching any data points, but it's as close as possible to all the data points, and that's a best fit line. Okay, that's really key. Don't make any of those normal mistakes because it drives me crazy. Okay, now we have a couple different types of relationships that we can see with a best fit line. If your best fit line is y equals mx plus b, that's the line that is your equation, and know that you've done this in math, it is linear. Your b is your y-intercept. It's wherever your best fit line touches the y-axis. And your m is your slope. This right here, this is the slope. And you can see that this graph has a negative slope. Okay? This is just some random graph I found on the internet. You can see that it's as close as possible to all the data points. It doesn't touch that many actually, but it's close to many of them. You can see here we've got a ton of points. Basically, as the husband's age increases, the wife's age usually increases. So I can go here and I can draw a best fit line right here. It doesn't touch all the points. That's okay. You can do whatever you want with it. That's okay. And then you'll calculate the slope based on the best fit line. You will not calculate the slope based on any of these points unless they're the 2 points you're using. So I could use this point and I could use this point, and I would use that to calculate my slope. You could use this one and you could use that one if you wanted, but you could use any point you wanted to calculate the slope. And this is a linear relationship when your best fit line is straight. A nonlinear relationships, there's quite a few of these. A quadratic relationship is when one variable depends on the square of another. So you can see this data, if I were to try and make a straight line for it, it wouldn't really be great. You can see that we've got this data point over here, and it would actually works better as kind of that curved line. And so this data has a quadratic relationship. I'm not going to make you figure out the equation for this. Okay, I'm only going to make you do the y equals mx plus b ones, but you should know how to do it, and I know that you've done these in math too, because I know that you have like a little song for it or whatever. Another nonlinear relationship is inverse. This is quadratic, but it's backwards. Okay, this is, I believe we call this a parabola in math if you're a math teacher. And you can see that we've got this kind of curved line, and this is a nonlinear relationship. It's inverse, which means as one increases, you can see as the volume increases, the pressure actually decreases. So this is an inverse relationship.